Hello, you are now entering the infinite void. Hang on tight. We cannot save you now.
Hello and welcome to this week's episode. I'm your co-host Jacob.
And I'm your co-host Matty, and today's episode is part 8 of our series Humanity of the Future on Planetary Expansion.
Yeah, so we thought last week we would break everybody's souls and tell them that the world's climate was having a crisis and that it was basically the end of the world unless we did something. And that's also still very true. But we thought this week we'd try and offer a little bit more hope and show that there is some light with some ideas around planetary expansion. And what we kind of mean by that is how humans might expand out in the solar system, how humans might live on other planets. And it kind of just falls back to that whole saying of like planet B instead of plan B, which I know is sometimes a bit of an argument for the whole climate crisis while they say there is no planet B. But
Mm-hmm.
I think in certain fields in science and in certain space exploration industries, I'd say that this is probably going to be a huge market. And if not a market, something that is probably needed just in case we don't fix everything. Not that we should expand out into the solar system if we can't be responsible, but it's better to send responsible humans out into the solar system instead of everything that we've done going off into the dark. So, yeah, that's the intro this week. What is your kind of thoughts on this kind of thing, Matty? Do you think that, like, before we get into this, because we've got a few notes, do you think that this is within humanity's grasp? Do you think you're going to see bases on the moon, bases on Mars, bases on the moons of Jupiter?
I think, firstly, I think it's interesting you raised the thing about the climate and sort of tying it into exploration. I really don't think there's a risk. It is sort of thrown around. Oh, we can't look after this planet. We're just going sort of ruin another planet. I just I don't think there's any risk of that happening because in sort of developing the technologies to tackle climate change, they're the same technologies that we need, and we're going to sort of talk about needed for other planets. So
Yeah.
renewable clean energy that we're developing to tackle climate change is going to be what's used on multiplanetary missions. We're not going to be sending fossil fuels to Mars to power things, and the same with efficient food and efficient use of water and oxygen and sort of technologies involved in construction that enable sort of simpler, faster home building. All these things that sort of come about from Earth problems and that we need to develop can be enhanced or can at least be used by space exploration. So that's sort of the first thing I wanted to say. So I think they're obviously two very different problems, but a lot of the solutions are the same or can be sort of enhanced by one another. So that's the first thing. And then in terms of timescales, I think in our lifetimes, I'm pretty confident that we'll see a sort of international space station style presence on the moon, maybe on Mars.
Okay.
I don't think sort of beyond that. So I'm talking 50 to sort of 75 years.
Yeah.
I think there will be a presence on those places where people go for sort of months at a time, maybe a year or two at a time, and then we sort of swap them out like we do with the International Space Station. That's my sort of that's sort of what I think is going to happen. And sort of at the end of that, we'll be sort of looking to expand and get sort of similar to the International Space Station again to get people out who aren't just astronauts and aren't just there to like do the very basics, but start to get scientists and start to get other people out there to do sort of research. So yeah, I think sort of 50 years of getting people there and getting a presence and sort of establishing ourselves, and then after that, sort of beginning to get scientists and stuff up there to do research. So and then after that, in terms of sort of mass habitation, I think that's probably 100 years plus personally.
Yeah.
So, yeah.
So it's going to be at least 100 years yet until someone can go on holiday to Mars.
That's just what I think. But
Yeah, no, I'd agree with you. I think you made a good point then as well about these technologies being created, because I think another thing as well for people to think about is, I know billionaires get a lot of hate because they have a lot of money, especially on Twitter. But I think one thing that is interesting to think about this is those people are going to be inventing or trying to create better versions of these technologies because they'll want to save money on their space missions. And that's probably a good thing, having private companies trying to also work on this that are willing to spend crazy amounts of money because it'll benefit them in the long run. Because it's like you're saying, all these things are like big answers to the problems that we have here on Earth.
mm-hmm.
And I do also believe that, like, when we do build on the moon and when we do build on Mars, it will obviously be with renewable energy, with sustainable infrastructure and all this kind of stuff, because it'll have to be for it to like work out there. Because as you're saying, we can't transport oil and stuff, and I can't imagine we would our future would be, oh, we found oil on Mars, let's go use it. But you never know. I would not put it without, I wouldn't say that it's not without a possibility, but who knows. But with that kind of thing, you could then see, then, well, okay, if all this stuff's got to be like self-sufficient for it to work out there, then why wouldn't we be able to apply that back here afterwards?
Yeah.
And I think obviously being multiplanetary is huge for us, because it's, as we discussed, I think in episode 4, even for the Great Filter, like that could be the thing. If you don't get off your planet in time before something like catastrophic happens. Because even if it's not climate change, it's like we've discussed before, there is asteroids, there are solar flares, and you're just kind of increasing your odds, aren't you, really, by having 2 planets instead of putting all your eggs in one basket. But yeah, so I got this little like intro to kind of kick it off. Yeah, because I do love an intro. But yeah, so it says, as intermediating as sending humans to another planet for the first time, maybe sorry, I don't know why I said that word weird. As intimidating as sending humans to another planet for the first time, maybe. Getting there is only half the challenge. The big problem is how humans can exist on the surface of the planet with an unbreathable atmosphere, cosmic radiation, and freezing surface temperatures millions of miles from home. I found this really interesting part on this article that was from The Scientist, I think, and they kind of talk about the idea of a window of opportunity. And they basically say how there is this lag time in sending people to the red planet because of the orbits of Earth and Mars. And the easiest way to get from one planet to the other is by using a trajectory called a Hohmann. Is that right? Did I get that right?
I think so.
There we go. Transfer orbit. My goal, by the way, for all the Infinite Void listeners, is one day I will be able to say all of these different names, like scientific terms, and not get them wrong or have to ask Matty if I've said them right. But a Hohmann transfer orbit.
Now you said it, I think it might be Hoffman transfer.
Okay. Well, I'm sorry if I've just called Hoffman Hohmann. Either way, something transfer orbit in which a craft moves in an orbit that gradually spirals outwards. See, I've messed that whole sentence up now. And it basically says that this is because of the way the planets rotate. Earth is inside the orbit of Mars and it rotates faster than Mars, so it laps it a couple of times. A Mars year is almost 2 Earth years. So you have to time the launch, and there's a window every Mars year, every 26 months at that time, called a Mars opposition, when Mars is close to the Earth. So every 26 months you have the opportunity to launch a spacecraft to Mars, and it's in this optimal orbit. So the plans for Mars are to send infrastructure first, and then 26 months later send a crew. Every 26 months you have the opportunity to launch a spacecraft to Mars in its optimal orbit. So sending infrastructure doesn't mean making sure there is air for the astronauts to breathe and food for them to eat. It also means sending and constructing a power plant, a habitat, rovers, and an ascent vehicle to allow astronauts to leave once their mission is over. So there's quite a lot of stuff they have to do before we can just have boots on the moon as they
hmm
say.
Yeah, I think sort of reading through this stuff is I think it's a very different mission to the moon and a very different mission to anything that we've done before because of this sort of time delay and the limited window in going to Mars. So with the moon, it's a 3 day trip, and as I understand it, we can sort of go whenever we want. There are going to be obviously optimum times of the moon relative to Earth positions. So if assuming we're launching from sort of Cape Canaveral or something, there's going to be times where it's optimal, but we can go relatively frequently. So it's conceivable that, in a sort of international space station style way, we can just send people up there regularly to build stuff and they can do short missions. We can give them enough oxygen and enough food for them to be up there for a week or two. They can do something in that time and then come back and then keep doing that. Um, the Mars one, it's because of this 26 months, it's a very different thing. It's not feasible that we can send something up there
Yeah.
and just leave it for 26 months and then come back and sort of carry on doing something with it. Because, firstly, we can't keep people up there for that long without having some infrastructure in place already. We can't just leave stuff sort of half built and come back to it because of sort of dust storms and things and solar radiation. It will just be destroyed. So it's going to be a very different mission. I think it's going to be a lot of sort of automation the first time round and sort of doing this robotically before we get people there.
Yeah.
I
You
there will
almost want
be
everything there, don't you? So the
yeah,
astronauts can land and it's all ready to go.
yeah, like it in terms of getting people there for a trip to Mars. That's already a massive feat. Is it a 6 month journey? I think so.
Yeah.
That's already so much more complex than anything we've done before. But then this 26-month wait is not. That's not even a feasible time for us to keep people there sort of a once off. We need a way in which we get stuff up there and start building it autonomously
Yeah.
or via robotics, so that when the next 26 months come by, there's something there for people to go to and can do something with, and then sort of build it from there.
Yeah.
Sort of that before anyone gets there, I think we already need to have a habitat which has oxygen and has food and has water
Yeah.
for people to do stuff with before they can sort of do anything else. So
Yeah, well, it's
it's
like you wouldn't send the astronauts up to orbit to build the space station that they're going to stay on. You'd have the
yeah,
space station ready to go for them to go to orbit to be on, and it's kind of
hmm
the same. It's a little bit, you know, what else it's kind of like. It's a little bit like all of the exploration voyages back in the day, with like
hmm
these long time scales of travel, like getting on a boat, having to either decide to take the resources with you to build when you get to where you think you're going, or deciding to use the resources there to build it.
hmm
And it's interesting. It's cool how we've got to a point now where like these distances are obviously millions of times bigger, but
yeah.
we're currently talking about using like automation to kind of tackle
Mhm.
the issue, which is something that we'll definitely use because as we've seen, like automation is probably like the number one used thing in space exploration. Like most
Mhm.
rockets are done that way. They're not really piloted anymore.
Yeah, yeah. I think it is similar to sort of um well, it's similar and dissimilar to those sort of first voyages by sort of Europeans over to the Americas, in that they take months rather than something that we can do in days, and you don't really know what to expect. So
Yeah.
you have a choice of, do we take stuff with us or do we try and just hope that we can use what's there? The difference is that we know that there isn't a lot of stuff we can use there. And in terms of things like oxygen, we know oxygen and water, we know that's very limited. So, um, yeah, it's quite similar to those sort of things, but also very very challenging. So yeah, Mars, I'm really sort of struggling to see even in 50 or 100 years how it could be done just from where we need to go from now. the moon, I think I'm much more sort of positive about. But
Yeah, well, they've got loads of different ideas for the moon, haven't they? Because like,
Mhm.
it's really weird, you know, because like as a kid reading like sci-fi comics and like having like Thunderbirds and all that kind of stuff,
Mhm.
you saw like all these like lunar bases, like one's in craters, one's in up in like orbit and all this kind of stuff, and it's just so cool to see. And I've seen a lot of like Soviet Union like space propaganda artwork as well, and it's really cool how they've got like those farms on the moon and stuff that they've illustrated and all this kind of like really cool stuff. I'll like collect a few and I'll put them as a link in the description as well for anybody listening, so you can go and check those out. But I just find it really cool because this kind of conversation is totally like blurring the line between what's science fiction and what's real, like this idea
Mm.
of actually living on another planet. But I'd agree with you because they've got so many ideas for the moon. Because I was reading one when I was doing some research for this over the weekend, and they're talking about the idea now that you might be able to live in the lava tubes on the moon. Have you seen this one?
I haven't. No.
So the way that the moon was created or something, they think when it was like had all its lava moving around,
Mhm.
the way that it dried, it's got like loads of hollowed out tubes, but they're like the size of like New York and stuff. And
Mhm.
what they think is like it would allow an area for humanity to like build a city in that is completely protected. It's not going to get destroyed by an asteroid or anything because it's like deep in the lunar surface in the tubes. But
Mhm.
I can't remember what instrument they used, but they basically like started scanning the moon and they found that it just had millions of hollowed out tubes from how the lava had dried when it was formed. And they're
Mhm.
looking into like using them now for like space caves.
Space cases.
But
Yeah.
it's kind of cool. I thought that I agree with you. I can see them doing a lot more stuff with the moon before Mars because, as you said, it's closer. That it's feasible times to get stuff to and from if there is a disaster or something that we hadn't accounted for happens.
Mhm.
And I think we probably really want to get there too, to attach stuff to it, to also look out at the rest of the universe because it would act as like a great spaceport. We kind of need it before we move over to Mars and stuff.
Mhm. Yeah. The moon one I think is really interesting in that it sort of feel obviously there are sort of things that need to change and ongoing issues, but it sort of feels like the technology is mostly already there.
Yeah.
Like obviously, in terms of creating something that's sustainable, perhaps not, but it sort of feels like we already have the technology that we could build something like the International Space Station, either orbit around it or a sort of on the surface moon base. And the travel times and the technology is there that we could already do this, and it would just be a matter of money.
Mm.
We could, like we do with the International Space Station, just put a moon base up and could send people there, for 6 months at a time, and could send a rocket every 2 weeks or so to sort of supply it. Like it feels like we could already do that. So yeah, the main one. Main one's really interesting, and I'm just looking at the lava tubes that you're talking about, and they do seem pretty cool.
Yeah. No, they do seem cool. It's a cool like idea. I hadn't really thought about it. It's funny
Mhm.
because when I first read it, I thought it was like clickbait for some crazy thing where they're like, "We found tubes or bases on the moon," and I was like, "Here we go." But then I actually started reading it. I was like, actually, no, this is kind of cool. They want to like
Mhm.
build almost like cities inside them.
Mhm.
But kind of going back to what you said at the beginning too, on like the whole thing around oxygen and like making use of like what we need. I found a little bit of info here on that, and it was the bit about oxygen. They were saying that the first big issue to address in setting up a Mars base is the production of oxygen. When you hear about producing oxygen on Mars, you're likely to think of the most basic human need to have air to breathe. And certainly, we do find a way to produce breathable atmosphere in a contained Mars habitat, but this requires only a small amount of oxygen compared to the big demand that of a propellant rocket that will launch the astronauts off the surface. So there's this whole idea as well around like, because we use oxygen for rocket launches and stuff too, that
Mhm.
It's funny, isn't it? Really, like what we need to survive and what we've used to travel, that they kind of like almost go up against each other, because that must be a logistical nightmare when you can only carry a certain payload, and
Hmm.
you obviously need propellant, but you also need like air for the astronauts too,
Hmm.
especially when there's not an abundance of it on the planet's surface. But
Yeah.
then they go on here as well to say, talking about like making use of what's available, and they talk about that Moxie thing, I think, which you mentioned on a previous episode, which is that experiment, which is the Mars oxygen in situ resource utilization experiment, which was which was handily carried to Mars along the NASA Perseverance rover that successfully landed in February 2021. Moxie is effectively a miniature version of a potentially much bigger device that can take carbon dioxide, which is plentiful in the Martian atmosphere, and produce oxygen. I think we discussed this on the Mars mission that we did when we were talking about what they
Hmm.
wanted to do with Mars One and everything. But yeah, because didn't that experiment go pretty successfully?
Yeah, yeah. So that is still running, I think, and it's this is exactly the sort of thing that we need to even consider doing this stuff, is being able to produce oxygen. That's, I'd say, probably the number one thing um, that we'd have to sort of contend with first, is getting a sort of breathable atmosphere. So um, yeah, it's pretty interesting, Moxie, and I'm not that familiar with the sort of science of it, but yeah, it's been running for obviously a few months now, and from what I've heard, it's been pretty positive. So
Yeah.
I'll just, you carry on, just gonna have a little Google while we're talking and see if I can see what's happening latest about it. But yeah.
No worries. So, obviously, as well, because anybody listening to this that knows me knows that I like to jump out into the infinite void a little bit and talk about crazy futuristic stuff. But we've also got the other end of this too, where if we're on much bigger time scales and we kind of go back to referencing the Kardashev scale a little bit, we're probably going to be looking at things like humans terraforming planets and using the energies from stars to transport material and energy to different planets and them be fully renewable. But one thing that really interests me is the whole idea of terraforming, because even though it sounds like super futuristic, we've probably got the technology to do it now, right? Like we could do it with nukes
Hmm.
on Mars. We could go and drop a load on the North and South Pole, whether or not that would be considered ethically correct and morally correct. But we've got the potential now to terraform planets. And I just find that so interesting, because like how far does it go, you know?
Hmm.
I've referenced this before, like when I think it's a Netflix show called Alien Worlds or something, and they just talk about all the different exoplanets in like the galaxy, and they're talking about like hypothetical situations where life might occur and all this kind of stuff. And they were talking about one where if a civilization just became obsessed with like going to planets to ensure its survival, like kind of like a brain in a jar situation,
Hmm.
how would they approach it? And it's very similar to like what we're doing, like how we would send technology there first to decide whether or not it would be suitable. Then we'd send technology there to turn the material there into structures that we can live in. And we'd kind of like prep it all, and then we'd kind of just show up, live there for a little bit, and then we'd use the star's energy to then move on to the next planet once we've exhausted it after like a couple of thousand years.
Hmm.
And I just find it really interesting because we're doing that now, but like on a macro level. Do you know what I mean? Like Mars already has a robot population. Do you know what I mean? It is literally a robotic planet.
Hmm. Yeah, yeah, I agree. The terraforming stuff sort of blows my mind a bit, and I'm not that familiar with a lot of it. But you could easily see for like things like Moxie how they could be scaled up just to pump out oxygen and sort of potentially make the whole atmosphere sort of breathable. So it's definitely a possibility, and yeah, I guess the other big one would be the biggest thing that I can think of is water. A lot of terraforming ideas and a lot of land and life as we know it rely on water, and sort of water in large big quantities. It's quite easy. Well, not quite easy. It's obviously very difficult, but to set up a little population where a biodome has a small supply of water and is able to grow a few plants and enough for people to drink is very different to being able to cover half a planet in water. So,
Yeah.
um, and I don't know of any way in which that can be done
Yeah.
without having a substantial amount of oxygen and hydrogen already there. And at that point, you sort of start getting into really, um, I imagine it'd be quite destructive, and I don't even know if it'd be possible in that you would have to sort of turn carbon dioxide into oxygen. You'd have to turn, I don't know, maybe hydrocarbons or something like methane into hydrogen, and you'd have to then combine the hydrogen and oxygen to turn into water. And yeah, suddenly you're using like all of the atmosphere up and all of the sort of organic matter just to make just to make some water that you can
Yeah.
use to produce a few rivers or lakes or something. So um, yeah, it's a weird one.
It
Terraforming.
it is. No, I'd agree with you. And some of the things that I've seen for it too are like really cool, where they go to like ice planets and
Hmm.
they try and heat them up by polluting it, stuff like that.
Hmm.
Yeah, I agree with you there. Maybe if there's nothing there, there's not a lot you can do with it, but
Yeah.
there are a few promising exoplanets out there that maybe are a little bit too cold, a little bit too hot now. But another thing that's cool as well is Titan. As This is my favorite place. I love talking about Titan. But I think it's really cool that like when the Earth's sun goes to being a red giant, Titan will kind of sit in the habitable zone by then. Because
Hmm.
right now it's all like icy and methane, isn't it? I think
Hmm. Yeah.
it's like a greeny looking moon. But it is interesting, and this ultimately will like decide whether or not humanity kind of survives. Do you know what I mean?
Hmm.
Because we were talking about this in the Kardashev scale one. We've talked about this in the Great Filter. We've talked about this in the Fermi paradox. We talked about this in simulation theory. Like we've literally spoken about this loads, and it's quite funny because I bet as a listener for the Infinite Void, if you weren't scared of reality, you probably are now, because we've pointed out like space debris, every kind of crisis that can happen, everything external to Earth, everything internal to Earth, and we are our own worst enemies. But I find this kind of discussion really interesting because it is literally going to be the decider on whether or not we stick around. Because like, if
Hmm.
we can't become multiplanetary, at some point our planet is going to run out of stuff. So even if we live in harmony, at some point we are going to run out of resources,
Hmm.
and that would be catastrophic. And if we do become multiplanetary, at some point our sun is going to either explode or run out of material to burn. So we've got to get to another star system. And it kind of just seems that like everything's a little bit fractal, in it. Just like
Hmm.
whatever your problem is, it's going to be worse in the future. like
Yeah, pretty
like
much.
like right, because like at the start it was like, oh no, our town or our village hasn't got enough stuff, let's go and see
Hmm.
what the other village has. And it was like, oh no, our city hasn't got enough stuff, let's go and see what the local towns have. And it's like, oh no, our country doesn't have enough stuff, let's go and see the other country. So now it's like, oh no, our planet's not going to have enough stuff, let's go and see the other planets. And then it's like, oh no, all the planets in our solar system are in danger because the sun could explode, let's go and see. And it's just going to continue. Do you know what I mean? Like we
Hmm.
are always going to be either looking over our shoulders or running from something. And I rate
Yeah.
that because it's probably going to make us a really strong species. It doesn't sound fun, but innovation and progression comes from that.
Hmm. Yeah, definitely. Yeah. We're the only sort of species that, so I don't know what you call it, like pushes the boundaries in the way that we do. We sort of do stuff that no one else thinks to do. So yeah, it's interesting that we sort of need to always do more, don't we?
Yeah, and it's funny as well because it's just like the more you learn, the more likely you're going to have like PTSD from it. Because like the person that knows nothing probably skips
Hmm.
through life having a great time, and the more you find out about existence, the more kind of terrifying it is. depending on which ways you look at it.
Yeah.
But another little fun bit that I had for this, because we've been talking about like the future of food and everything, and it was included in some of the research I found, was this idea around printed noodles. And it's this material research corporation in Austin called Angen Contractor, and it has NASA funding, and they're basically they're developing a 3D printer for hot food for deep space missions. And the food powder is UV sterilized, fortified with nutrients, and has a shelf life of 15 years. How insane is that? That's what you need to stock up your bunker with. But so far they have printed noodles, turkey loaf, basil paste, bread, and cake. How
Delicious.
awesome is that? Because we've discussed this too. Like, you really do need to be able to like 3D print food or have some form of creating food in space if you want to go on long journeys. And I just think this kind of stuff's so cool, because that also, if we can figure out a way to make it cheap, can solve a food crisis. Do you know what I mean? Like ramen has already solved the food crisis once. We're going to do it again in the 21st century, but just 3D print it.
Yeah, I just noticed the last line of this. They won't taste their creations until a new food only printer is used for the job.
But yeah, I thought that was cool. Another couple of things that they touched on as well was obviously solar power for Mars, which is a biggie. Solar panels, a big one. But I was thinking about this. How likely are they going to use that on Mars? Because obviously there's a lot of dust. It's further away from the sun. So I can't imagine its intake's going to be as good as it is here on Earth. I would have thought that nuclear power would have been more the way to go on Mars.
I think it'll be probably a mixture of both. The problem with nuclear is that it isn't truly renewable, in that we would have to go and restock it occasionally. And if you want to take quite large quantities of stuff that could power stuff for multiple years, that's a lot of radioactive material to be putting on a rocket potentially. So
yeah, that's a very good point. I hadn't thought about that. Okay.
So yeah, like there is, I think they had space treaty bans
nuclear stuff in space, isn't it?
Yeah, nuclear weapons. Yeah, so there would be probably a bit of a problem with vast amount of radioactive stuff. So I know things like Voyager and stuff are nuclear powered, Voyager spacecraft, because obviously at the edge of the solar system they don't get much solar power. But yeah, in terms of putting enough radioactive stuff on a rocket that we could power a base or power a small city or something, it's a lot of stuff, or we have to be doing it very regularly. So okay. I think probably short term, while we're still building these things, nuclear would definitely be the way to go. But I could definitely see a sort of group of nuclear powered robots or things being used to then build a vast solar array that can power stuff. So yeah.
Okay.
Yeah. The other thing would be sort of by that point, if we were able to perfect things like space elevators or wireless power transfer, and that the whether the solar powers could be positioned sort of in space rather than even on Mars, and then you wouldn't have any of the issues with sort of the panels being damaged or covered with dust and stuff. So yeah,
that's a very good point. I hadn't thought about that. It also says here as well that one of the concepts was to have a solar panel station, but have robots that are nuclear powered cleaning the solar panels.
Oh, there we go.
It's kind of similar to what you said, to be fair. And then the last little bit really that I had for this was on like Mars propellant production and transportation stations, because I hadn't really thought about this either. And they basically go on to say that when you're living so far from home, it's efficient where possible to use the resources you have in place. This is called an in-situ resource utilization, which is kind of what we were talking about before with Moxie. And it means that astronauts would do the best they could to grow their own food and use the dirt, rock, and other resources of Mars for their basic necessities. Shown here is a propellant production of transportation stations located not far from a facility that mines regolith Martian dust. How to create propellant is a highly experimental idea, but some thoughts could include removing certain gases from the Martian atmosphere or environment to fuel rovers or other vehicles on the surface. So I'll include this image in the notes too. But basically, what it kind of looks like is almost like, I don't know, like the opposite of what we do here. Instead of pumping stuff out, it's sucking stuff in. But it looks interesting.
Yeah.
What kind of transportation propellants do you think we would use for Mars? It's probably going to have electric vehicles, right? Or
yeah, definitely electric vehicles. I think rockets will probably be, and I have seen them sort of looking at this, is using sort of water on Mars, the ice on Mars, to develop sort of oxygen and hydrogen based fuels. So that will be, I imagine, the propellant for rockets. But yeah, definitely, I think, as we said, everything will be electric or potentially nuclear. Actually, on the planet, seems like the obvious way forward.
Yeah.
Yeah, I'm sure someone will come up with a way to put an oil pipeline to Mars.
Yeah. No, for sure. I actually saw a couple of things yesterday from Lockheed Martin that they were showing all of their Mars concepts. Have you seen some of them? It's pretty cool. They've got like a rocket that is going to be reusable, that can take off from Earth and land on Mars, and then take off from Mars and land on Earth. And they've got some cool like satellites and stations that they want to build and stuff like that. It looks kind of interesting. I'm excited for the future of space exploration because I feel like it's just getting started, you know?
Yeah, definitely. Yeah, the transport one, I think, is definitely a sort of area where we sort of stagnated for quite a while, in that the main stuff we have is obviously big rockets, which you've had for about 50 years, and then sort of rovers and sort of things like Perseverance, which you've had for a couple of decades now. We've not really seen anything new develop. We've not seen any sort of thinking about like the Martian, the sort of trucks that he drives around and that. Yeah, things like that. I've as a kid, I would have thought those would be things that we sort of had by now. And if we went back to the moon, we'd be sort of trying to use, because those are the sorts of things that ultimately we're going to need, because I can definitely imagine sort of getting to Mars and us being able to move around a base because of a storm, or move large rocks because we want to build something, but we don't sort of have that capability yet in able to sort of transport anything on a planet for a distance of a few kilometers, say. That's quite heavy. We don't have anything like that. So yeah.
No, I'd agree with you. Have you got anything else you want to add to this? Because I got to talk just a little bit about our special episode next week.
I did have one final bit, which was on the actual basis themselves, just because you talked about sort of printing and
cool
sort of in-situ resource utilization. So this was one. I'll drop you the link now so you can actually see it as well while I'm talking about it. But it was about building actual bases on Mars.
Nice.
Using these sorts of things. So I think I've spoken in the past about sort of using 3D printing to build a Mars base. So this is a company, and I definitely recommend people sort of have a look at sort of them if you're interested in sort of things, called AI Space Factory. And they actually won NASA's 3D printed habitat challenge in 2019. So they got quite a bit of funding to
I think I've seen something similar to this on YouTube or something.
Yeah, they got quite a bit of funding to look into this. And their system uses basalt, which is crushed up and can be found in the Mars rocks, and a bioplastic, which they think could be grown on the planet using sort of engineered plants. And it creates this sort of printable, strong, plasticky, rocky sort of material that they think they can make actual habitable things from.
Wicked.
And if you're on the page, about halfway down, there's this picture just below organic inspiration. And they're sort of using, it's quite common now to try and weave in organic structures and make sort of man-made structures organic that's because they're usually quite efficient. But it's basically a massive egg.
Yeah.
Massive egg, and it's got sort of 4 levels in it. And this is exactly the sort of thing that I can see happening as we start to move from that initial sort of temporary structures, like just getting people there, getting people used to it, to sort of actually building a base.
Yeah.
Because I think it's feasible that we could, as I said, get an International Space Station style thing up there. International Space Station is about the size of a football field, isn't it? 2 football fields. But sort of basically a few shipping containers that a few people could live in for a few months at a time. But then sort of moving beyond that, I don't think it's feasible that we can transport the stuff to build 10, 20, 30 houses and build a research lab. That we're going to have to sort of develop that stuff up there. So this sort of thing is definitely, I think, the way forward in terms of building habitable Mars bases.
No, I'd agree with you. I can see it going that way. It looks kind of cool as well.
Yeah,
looks interesting. I like 3D printing stuff at the moment. I'm super interested in it. I've got a friend that's just bought one, so he keeps sending me all the stuff that he's printing, and it's super cool.
Yeah.
But yeah, that pretty much does it then for this week's topic, which was all about planetary expansion. Just before we end this week's episode, I wanted to say a little thing. So our next episode, which is going to be in a fortnight on September the 15th, is going to be our 1 year birthday, if you call it. I don't know what you call it, but it's 1 year since we started the podcast. There is currently a poll on social media for you guys to go and vote on what you'd like it to be. There is a live stream, there is guests, or there's a longer version episode special. So go there and vote. We look forward to hearing and seeing you all for that episode in 2 weeks' time. It's crazy that it's been a year since we started this. It's mad because we started it in lockdown and when it was dark before 8 p.m. and it's dark before 8 p.m. again now, and we're moving back into that cycle. So it's fun, but yeah, it's been wicked and I'm excited to do that episode. We got a few ones coming up again that I think will be fun for us to do again, like Halloween and our year in review at the end of the year and stuff like that. So it'll be a fun time for the Infinite Void. So head over on our social medias and check that out, vote and follow us, because you can keep up to date with everything that's going to be going on with that, so you don't miss anything. And that is at Infinite Void Pod on both Instagram and Twitter. If you want to follow me or Matty, I'm at Jacob E. Carson, and Matty is at the Matty JMP. You can also go and follow Twope News, or This Week on Planet Earth, which is at Twope News on Instagram. And that is basically a weekly news show on everything space and science and tech. It was the news section for this show, but we turned it into its own thing for YouTube because we thought, let's make more visual content. And yeah, guys, we will catch you next episode for our 1 year special. Hey everyone, we wanted to take a moment to tell you about our brand new Patreon page.
Yeah, so we've devised a load of new goodies that are neatly packaged across 3 different tiers for you.
Tiers start at £3 and go all the way up to £10 a month.
Just to say, the Patreon is in no way an obligation, and we're going to continue making the podcast as it is freely available across all the platforms. But if you'd like to support us and show your support, you can now.
So yeah, head over to patreon.com/Infinite Void Pod for more information.